Hello, everyone, and welcome to our .NET Community Language and Runtime Community Stand-Up. I think now I messed up the name because I apparently cannot remember what show we're on. So today I have a bunch of special guests with me. So I think a few weeks ago we talked about source generation, and that seems to be everybody's favorite topic about how it works, what you can do with it, what the pitfalls are, and all of that. And so we decided to bring on the experts and dive a little bit deeper to talk about what this feature does and how you can use it. And so how about we introduce ourselves? My name is Immo Landwerth. I'm a program manager on the .NET Platform team.
So I'm Jared Parsons. I'm the dev manager of the C# compiler team.
I'm Sienkiewicz. I work on Jared's team on the C# compiler, and I've been largely leading the source generators effort for the last year or so.
Hi, I'm Mikayla Hutchinson. I'm a PM architect on the .NET team.
That sounds great. So let's talk a little bit about source generation in a bit more detail. So basically, people always try to write code by hand, right? And then every once in a while, then it gets too tedious. People want to automate some stuff, and then interesting things are happening. And C# added source generation, I think, I want to say like a year or 2 years ago, maybe. And so how about you give us a quick overview of what this is and how it works and what you can do with it?
Yeah, so I mean, we introduced it in Visual Studio 16.9. It was in preview a little bit before that. So you had to have like certain flags on to use it, but we sort of gave it to the public in 16.9. And the idea being that where before we've had lots of technologies that you could do source generation by looking at things and maybe use the Roslyn APIs to introspect the code. It was never really integrated into the build pipeline in a very easy to use way, and it was certainly nothing the compiler understood. And so the idea behind the integrated source generator feature for C# with the compiler was that it would just be work out the box basically as part of compilation, and that we would have a deep insight into it. And so you could actually just write these little plugins that would run inside the compiler and generate code as part of the compilation process rather than having to hook things in yourself. And that obviously has advantages because we can give you all those APIs, we can reuse the models we're looking at, we can do things like parsing for you, as well as just making it run really easily out of the box in the IDE, and as well as on the command line builds and things.
Awesome. Jared, you were about to say something? No?
No. Sorry.
Okay. So one question people have is like, how is this different from, let's say, other things we've done in the past, like T4, for example?
Yeah, I mean, I think the main difference, and I mean, Mikayla can speak a bit more about T4, but generally that's more of a kind of a general purpose transformation technology, right? It really is a macro language, and you can generate all sorts of things with it, and it really has its own tool set and its own set of kind of life cycle about how you use it to generate code. And then source generators, the integrated thing is very focused on generating either C# or Visual Basic. At the moment, you can only create that code. And also it's that it really tightly integrates, right? So where with T4, you would use it outside, and you could use other generation technologies as well, and then just pass those generator files to the compiler. Here, you generate the code inside the compiler. So you don't pass the generator code, you just say, oh, this is the algorithm I want you to run, and the compiler actually runs it for you. And so it's very, very tightly integrated into the IDE and the command line. And I think that's one of the biggest differences. And it means that you get access to all that, the sort of the goodness of the compiler as part of generation. And there's kind of a parallel and an analog really with when we introduced analyzers in Roslyn for the first time, in that you could always do code analysis and you could do static analysis, but it wasn't integrated into the compiler. So you had to run it as your own step, whether that was in MS Build or doing it on your CI builds afterwards. And we said, well, actually, how about we bring that step into the compiler so we can do it very tightly coupled. And really, that's what we're aiming to do with source generators as well, is just say that rather than using external tools and different pipelines and things, really just allowing the compiler to do that for you. So.
And one of the other things, like if you look at like T4, like comparing source generators to like other techniques like pre-source generators, like T4 actually has a pretty good experience in Visual Studio. Like you open it up, you have the files, they can run during build. It is a kind of a part of the Visual Studio experience. T4 had to put a lot of work into that to make that happen. Like that is not something that just exists. Like that is design work that T4 did that is stuff they have to maintain? How do you integrate into the MS Build pipeline? How do you make sure you show up in Solution Explorer? How do you make like the little clicky, expandy experiences work? And that is something that kind of any generator that is kind of trying to plug in the pipeline has to rationalize with, like resource files or another one, an example of source generation, which also has to have similar kind of experience things. And as Chris is saying, it's like one of the great things about source generators is we kind of handle all that nonsense for you. It's like once you have a generator, it has a defined way that it just exists in the Visual Studio experience. And generator authors can focus on how do I generate the right code, and pretty much all the other aspects of the experience kind of just you get for free.
Yeah, is it fair to say that source generators are basically the more sophisticated version of what C++ does with the preprocessor, where you basically get to emit some code and then do something smart with that?
Oh, God. Yes, because like one thing that C++ is doing is like the preprocessor and kind of their template engine. It's largely text transformation. It's text token transformation. It is basically, I mean, macros are really just like take piece of text and like expand piece of text. I would say that's actually closer to like how T4 works in terms of like kind of expanding text. Source generators are different in that the C# compiler has an entire API that lets you inspect deep questions. Like you can look at the syntax trees. You can ask symbolic questions like hey, there's this word like, INT, like does that represent a type? Is that like a value? You can inspect references. You can look at like what options were passed to the compiler. Like you can get deep insight into everything that's going on. And so you can go way beyond like simple text transformations.
Yeah, we have this the fancy term, right, which is compile time metaprogramming, just what our sort of highfalutin version of what it is. But essentially, it's just that you can actually run arbitrary code at compilation time. So where the macros are limited to, like Jared said, just expansions and replacements, and you can do some sort of really, funky stuff with that and emulate that. Whereas here, really, we just say, write a program whose output is source code. And we will run that program and produce that source code. So you're not limited in any way by what you can actually produce. And as well as, it being a program, you have access to all the compiler internals. So as Jared said, you can ask questions and you can find references and resolve things. And you don't have to do all that stuff yourself. You can just rely on the compiler's sort of battle-hardened APIs to do that.
Yeah, so one question that popped up in chat by Mark is source generators don't depend on Visual Studio versus T4 as a VS feature. Can you talk a little bit about the relationship there?
I mean, from a source generator point of view, they depend on the compiler, yeah. So I mean, the IDE has tight integration with them, but they are built into CSC and VBC essentially. So they run on the command line and in CI builds. I'll defer the T4. I mean, I think you can use it outside of Visual Studio, right? But
I can answer that one. So T4 is available a few different ways. One way it was available was as a single file tool in VS. It was also available as a CLI tool, texttransform.exe, and MS Build tasks. Now, it did ship with VS, and there was no way to get it aside from that. The official one, at least. I actually re-implemented T4. That's available open source, so you can download that and run it any way you want, including as a .NET global tool.
And I think generally speaking with T4, I think the integration point is more like when you mess with the template in VS, it basically runs the generator and emits the source file, but the source file is generally part of your code base that you check in, right? So basically every time you, let's say, download the repo, you generally don't have to rerun the code because the code is already there, versus in source generators, my understanding is the code is generally not checked in. The generator runs every time you compile, basically, right?
That's the way it was done in the VS MS Build targets. I've been writing some that work a slightly different way in that they emit it into the intermediate directory and inject it into the compiler. So it's a little bit more like the source generator experience, but they're really not T4 really is not good at doing some of the things that source generators can do. Like, for example, if you want your T4 code to have access to the rest of your project, you really can't do that without a multi-stage compile, which is not an easy thing to do in MS Build.
Yeah, that's the thing that I remember. Like every time I did something fancy in MS Build, like generating a file, having that all nicely integrated with like clean and like, register the file, cleaning it up, getting into the right position. It's all doable. It's just, it feels like it's way worse than macro file yeah, it's basically way worse than, editing the code by hand most of the time, because you end up like all the mechanics and like you can shoot yourself in the head multiple times before you actually get it working. So one question I have is like, how would I choose between T4 and source generators? Like, what is an example of something where source generators are really good at, and where's an example of where T4 is really good at?
Well, if you want to generate C# code based on the contents of your project, then source generators are the clear win. T4 is a really, really bad fit for that. If you want to generate some arbitrary text file, then T4 is the clear win. That's not what source generators are for. There are things in the middle ground. You could actually, if you wanted, use T4 to implement a source generator. Like you could use T4, write your template to describe what you want your generated C# files to look like, use T4 to generate a class from that, compile that class into a source generator. So they don't necessarily have to be mutually exclusive.
Yeah, that's my general question. Like I think like with T4, it's kind of like, Razor pages basically where you have inline code that controls the logic of the generator, and then the code you output is just text inside the same file with different markup, right? Versus the source generator, my understanding is I basically get an API that amounts to give me a string, and then how you construct that string is entirely left as an exercise for the reader. We don't really give you much for that. Is that still the case?
Yeah, so from the source generator point of view, it really is, you can add like multiple files and things, right? So you can actually generate multiple source files, and how you construct those source files is completely up to you. And we obviously have APIs in Roslyn that help with that. But it's a sort of very scoped in that sense that all you can do is add source, whereas with T4 is a much more general transformation language that can write things. And I think it's what Mikayla was saying in the middle ground. I think certainly some of the things that T4 can do are a lot simpler than writing a generator, right? So if you really do want to just say, oh, I've got this block of C# that I want to duplicate based on some input, right? That's where T4 is like a great case for that, because it's very easy to do it in T4 and it is really lightweight. Whereas to spin up a generator to do that, there's a lot of ceremony. You've got to build a DLL and a project and get it all working. And so like, it has advantages, but it's also just a heavier weight process. So there's definitely something in the middle there where, if you don't need to introspect your code and you just really need to do some lightweight generation, then T4 is great for that, even with C#.
Yeah, I think we could probably summarize the distinction as source generators give you a better experience if you're generating C#, and they have access to the data that the compiler has, whereas T4 files are a bit simpler. They run in isolation. They can generate any text you want. You can also use T4 to generate classes that would do what the T4 template would generate, that you can then compile into your own code. So they're kind of a lot more flexible and general purpose, but they're not as good at the things that source generators are intended to target.
Yeah, the other interesting thing with Swatch Generators is they have a really nice packaging experience, right? Because basically, if you do something, let's say you generate code for a serializer or something, you can put it in a NuGet package, and then people who reference the NuGet package, they basically, similar to the library, they also would just silently pick up effectively the source generator. And so the user doesn't have to do any magic gesture, despite of how the source generator picks up the fact that you have to do something. Maybe you have to have a partial class with a certain naming convention, or you maybe have to implement a certain interface or whatever the conventions are, but that's basically it. And then the thing just runs, right? Versus with T4, it's more like it's part of your project, right? It's kind of like a source code file that you manually added to your project, and then it's yours, and you mess with it. And then if whoever wrote the template wants to update it, well, then you can upload a new version somewhere, and then people have to download that version, but there really is no, packaging experience per se, right?
Yeah, if you wanted to do that with T4, then you would really use your T4 files to generate classes and then compile those into a tool and then inject that via an MS Build target or something. So you basically have to do the same kind of level of ceremony anyway.
Yeah, and I think that like another way to think about it is like with source generators, like with T4, they're the author and the consumer are generally the same person. Like if you are using T4, you are the writing the T4 and you are consuming the output. With source generators, it's much more likely that the generator and author are two different people. It's, the majority of source generators can be written by library authors who kind of package it along with their library to kind of enhance, all the capabilities there for customers to use. And so the way in which customers will be interacting with generators is things like you said, like adding an attribute here, implementing an interface there, and kind of letting the generator take over for you. And so there is kind of a difference of a split there. I mean, there are a certain number of people out there who will be I am writing a generator for my own consumption. The compiler team does that. We love it. But that is kind of probably a little bit in the smaller case now. I imagine it will grow over time, but the majority use case will still be the split between kind of the consumption and the authors.
Yeah, so one question we get here in chat, I have to scroll up a little bit because I've already scrolled by it. It's this one here. With the idea that source generators should replace or be fast alternatives to reflection, what about non-C# languages?
In what way? So I'd say that there's kind of like, we have generators for C# and VB. I know that, for instance, F# has type providers, which is a similar vein of technology. It's implemented slightly differently, but it's like a very similar kind of approach to things. And so I think for those languages, I mean, source generators is something that you can kind of like any language could replicate in their tool chain or the build pipelines to make it easier. I mean, I think that the real kind of leg up that Roslyn has is that Roslyn and C# started with analyzers 5 years ago. And so we have a very battle-tested, expressive API for introspecting the compilation, looking at all the tools and getting like really deep metadata. And that is not generally available in most compilation pipelines. Like there are definitely like tools there. Like I know, like I believe like Rust has some good tools for how they inspect their code. There, some of the like the Clang engine is really good for kind of looking at code, but it's, to my understanding, I might be wrong about this, but I do not believe that they have integrated those APIs as a part of their existing build process. Whereas with Roslyn, we already had. Adding generators was more plugging into an existing pipeline, whereas those languages probably have a bit of work to do in order to build that on top. I think something like T4 level support for generation is probably kind of the easier baby step in that direction, because that's something you can kind of do outside the compiler. You can help integrate it into a pipeline pretty easily, and I think you can find good examples of that type of technology in a lot of other languages.
Yeah, that's an interesting point. Like I think if you look, I mean, one thing I want to comment on is like replace reflection or fast to reflection. It's kind of, it depends on what you mean by that. So like, I work on the library side, on the .NET side. And so we, of course, are heavily looking into source generation for various areas. So the two prominent example that we're looking at right now is JSON serialization, and the other one is, for example, regex. And they both have very different characteristics, right? So regex, for example, you effectively, the way regex works, right? You take a regex string, you parse it into some representation, and then you create some sort of, automaton out of it, and then you interpret it at runtime usually. And if you look at the regex APIs, there's a way to compile it to IL using refemit, and that is really just a perf optimization. So like you could imagine that, whatever this, interpretive system is, kind of like, it's not the most effective or efficient way to do it. And the source generator would do pretty much logically what IL emit would have done. The only downside there is you no longer emit IL, right? So some things in IL are nice because you're not confined to what C# can do. You can just do whatever you can do in IL. and you can jump in pretty much anything you want, which is a bit harder in C#. But the downside is also good luck debugging this and good luck reading this, right? So like you better get it right. And generally speaking, ref emit is something that the name implies it happens at runtime, right? And that works great on environments where you have a JIT where you can actually take the IL and now actually emit native code and run it. Doesn't work super well in environments where you don't have that. I mean, I think we now have an actual IL interpreter for iOS, but then, well, that one is not faster now than just taking the NFA or DFA from the regex engine and interpreting that, right? You just do it now the same thing. So, but if you do source generation, the nice thing is you just spit out the whole thing as the regular source files, and you get all the benefits of regular compilation, right? It's a closed system. It's all static. The trimmer or linker just works the way you would expect, and you can debug it. Obviously, you can step through it if you ever wanted to. So there's a whole bunch of benefits you gain from that. So I'm not necessarily thinking of this as an alternative or as a better system. It's just an alternative system that has some characteristics that are sometimes nice, but it doesn't necessarily mean it's faster than reflection emit. In fact, reflection emit in many cases is actually decently fast. It's just that it happens at runtime, right? So you pay potentially some startup penalty for that, and of course, it doesn't really work in environments where you really want static behavior. I think in many cases, also when you look at serialization, for example, our source-generated serialization is actually not faster at all. It's actually about the same performance that we get from the regular one. And that has more to do with the way we do serialization. That's not necessarily intrinsic to source generation. It's just that if you think of serialization, there's all these like customizations and hooks and callbacks that you can invoke where the user can say, oh, I have this casing policy, or, oh, I want this collection to be handled like that. And when you have to do that, well, that's really what dominates utilization costs. Whether the thing was done by reflection or source generation doesn't really make a huge difference anymore. So our general stance is when we design features for which we want to use source generation, we try to make the feature work without source generation as well. So like, you don't have to rely on source generation for correctness is the goal. The tricky part right now is because we invest in the linker is that for the linker, you kind of have this problem that there's such a thing as correctness. If the linker removes stuff that you need at runtime, then your program is no longer correct. And in that case, source generation is easier to get correctness because you're describing a static system, right? But I think as a general library author, you should not think of source generation as a faster or better reflection. It's just a different kind of reflection that happens at a different point in time. And that comes with different trade-offs, right? So it's a tool in the arsenal and choose it wisely. Okay, just read through the questions right now. So that's an interesting question from Jose here. I need to obfuscate my software. How does source generators interfere on it? Or does it or does it not?
So they should play nicely. We're generating source files before we emit the assembly to disk. So we take your input source, we run the source generator, add some more input source, compile all that to an assembly, and then you can then obfuscate that as you would normally using whatever tool you want to use. So because we're running in the compiler, we happen before any of the obfuscation happens. So they should just work out the box nicely.
Yeah, that makes sense to me. So one question that I also had was this one here. Has the way we debug source generators improved? Last time I tried working on a source generator, I had to use debugger.break. Is that still the case?
Yeah, so good news. In Visual Studio 16.10, we have a preview feature that we shipped. And we have a post about it, but hopefully people, if you've not seen it, to go play with it. And it's essentially an F5 experience now for source generators. And so what you can do, and it's always been really tricky to debug anything that's in Roslyn, right? Because with analyzers, you're running inside the compiler. And so the way we fixed for analyzers is that you could have analyzers inside of V6 that would then run on experimental Visual Studio. So you'd say, I want to debug this analyzer. You put it in a V6, we'll run an instance of Visual Studio. You open a project, and those analyzers then run. And that never worked for source generators because you can't ship generators in a V6, right? It's not a concept that we have. And so what we've done is we've created this thing called the component debugger. And it allows you to kind of skip that whole Visual Studio thing. And rather than attaching to a Visual Studio instance, you can now just debug a compiler instance. And so you can put your generator as one project, and you need this little string. It's in the release notes, but we can type it up in the chat as well, which is just is Roslyn component. And so you put is Roslyn component true in your project file. And that then enables a new debugger option in the debugger project properties. And what that allows you to do is it will give you a drop down of all the other projects in your solution that reference that generator. So you can have your little test console app, which is like, I want to debug my generator running on this console app. And then when you F5 on your debugger, we will actually open the compiler to build that project and attach the debugger. So essentially the upshot is that you can just literally stick a breakpoint in your debugger, you hit F5, and then there it is. You break into your execute method with the code that it's running on. So we're doing lots of kind of voodoo under the hood, but the idea is that it's just now very, very simple. And this works for analyzers too. So if you want to debug your analyzers without launching a whole version of Visual Studio, you can just use the component debugger. Like I said, it's in preview. It's behind that is Roslyn component flag because we're still not, necessarily ready to say yes, this is a supported thing. But we've been using it a lot. A lot of people have, given us good feedback on it, and certainly it now, makes it a much quicker inner loop to debug generators. So hopefully that will do. And if you do find bugs with it, let us know. If you need, if there are features that are missing, we're still, actively building that out. So
yeah, that's really great because I like it's always like a cool demo when you F5 something and then another version of Visual Studio pops up. But at the same time, when you do this 100 times, it gets old very fast because if you wait for the IDE to load, right? But it's certainly that's a super cool thing. I will definitely work with that. So we have a question on sourcing. I think Jared or somebody else probably already responded to it.
So how do generators work with SourceLink? So there's a couple of different things you could be asking with that question, and I'm not sure which one you are. But generally, the way SourceLink work is SourceLink effectively says if you're building from kind of Git or your GitHub or any kind of like hosted repository, it basically inserts a JSON file into your PE, which as a resource, which basically just says it introduces kind of a mapping, and it says, hey, if you're looking for the source code for this application, start at this GitHub repo, start at this SHA, and then everything is a relative path off this commit. And so it's just a very easy way to kind of like make it, particularly open source applications, just to make it very easy to like go from a DLL to a like awesome debugging experience. So what happens with generators though is generated code. Like it's not going to be checked into your repo by default. Like it's something that's generated on the fly at runtime. So the way it works is by default, all generated files are just embedded in the PDB as source. So C# has essentially supported the idea of embedding your source code into the PDB for an easy debugging experience for many years now. And with generators, we just kind of layered on top of that. We just said, hey, okay, all the generated files, just go ahead and put them into the PDB. And what that means is if SourceLink is available, that generally means your PDB is available. And so if you're using a generator, it's just going to work. It's just going to, the debugger will have the PDB, it will know it's an embedded source file, it will pick it up and just start working really kind of like very easily. Like that's the experience. We went from making that experience like basically as magical as possible. And so by default, if you don't touch anything and you have the PDB, it will just work. And as Immo said, like this is one of the big, like really awesome things about source generators is you can debug through a whole bunch of code that you suggest exists as reflection.emit. Like if you've ever like played with regexes and you're like, I wonder what's happening. Why is my regex going wrong? The answer is you go to Stack Overflow, you paste your regex, and someone like interprets the non-deterministic finite autonoma. But like now, like you could actually like it's a really cool thing. You could actually step through the generated regexes now. I mean, it's still a non-deterministic finite autonoma. It's not the best code you've ever stepped through, but you can do it, and it's really kind of interesting to like see it happen. So yeah, it's meant to be a pretty sweet experience.
Yeah, I think for serializers, it's probably slightly easier to understand than for regex. Regex is probably going to be switch state and then a giant case statement of like a whole bunch of numbers, which is probably not very helpful. One question we got here is there no connection between source generator code and the generated code? I'm not sure I understand the question, honestly. If I debug into source, generate code and someone able to see the original source generator code?
You don't.
You won't see the code that generated it, but you'll see the code that came out of the generator.
Oh, I see. Yeah. So if you're basically building a project with a particular source generator, the generator itself is nowhere near embedded, but the resulted code is, right? So you can't really debug through the generator. You debug through the generated code, right? Yeah. Yes. That makes sense. The question regarding the debugging, is it available in the currently public preview version of VS, or is that an internal?
Yeah, it was in preview 2, I think, of 16.10 it came out. Immo, I actually posted a link in the chat because I can't post to there if you want to post it in the comments.
I see. Okay, let me just copy paste it over.
So there's a few little hoops you have to jump through to turn that on, but they're in the release notes.
Let me just scroll up a little bit to see whether there's any more questions we skipped. So so there's one question regarding T4. Can T4 be used to create project templates for VS5? I'm not sure what VS5 is, but
yeah, you can't create project templates with T4 because the project templating system isn't extensible in that way.
Yeah, I think like as far as templates go, like project and item templates, I think they have their own little language with like placeholder stuff that you can fill in, right?
Yeah, I like the idea. Years and years and years ago, back in MonoDevelop, you could actually write project templates with T4. But yeah, now we have the standardized project templating system that works across VS, VS for Mac, VS Code, the CLI, and so on.
Right. Yeah, that's the benefit and downside with sharing stuff. You all share the same limitations. So I think there wasn't another more question. Oh yeah, there was one thing that not directly to T4. Let me just click this guy here. But it would be nice if you could just reference the CS file in the custom tool window property in VS properties window, and it runs in a similar way to source generators. It's kind of related to this earlier thing of like with T4, what's nice with it is because it's part of the project, editing the T4 template and getting the output is fairly seamless. What I found when I played with source generators is that because they're really like designed as a compiler plugin, it's kind of like there's a different, at least you have a separate project. And then even that, referencing that is not super straightforward, right? There's like some custom thing you have to do. Is this something that you guys are thinking of?
Yeah, I mean, we're sort of very much aware of there's a lot of paper cuts when trying to use source generators locally on a project. And Jared said that like when we really designed the feature, we had in mind that it was going to ship as NuGet packages and you would be using these as library authors. And it's been interesting how many people actually have, like, as Jared said, we do it ourselves, referencing sort of like privately, where they really are just projects that then you're not going to ship them. You just want to generate some code for your own thing. And so right now there are some hoops to jump through, and there's some sort of MS build foo you need to paste in to make it work. We don't have anything to announce, but we certainly have some plans and some ideas around making that a lot simpler. I mean, this kind of, you could imagine just having a single class would be lovely, actually. I mean, that's a really nice, you just paste it in and we do the rest for you, right? But even in the shorter term, just making referencing generators locally easier. And it's true of analyzers too. And we've had these same problems for like 5 years. It's just that it's not that common to do it with analyzers. Where we're seeing people really wanting to do this with generators. So, it's a nice problem to have. It means that people are using them and finding new ways to use them. But there's just some rough edges that we need to sort out. We have, like I said, we have some ideas about how to fix that and how to make it work. But it's not the most trivial problem to solve. So it's still kind of on the drawing board at the moment.
Yeah, I mean, everything Chris said. I mean, I think like we kind of started off as Immo kind of like started this whole chat off with like, what's the difference? Like, is this just like a version of like the C preprocessor? The C preprocessor is great. You just put like pound define and like, bam, you're gone. You're off to the races. Like we do want to get to a place where for kind of like local iteration, it is getting closer to that. Like Chris said, like some of the ideas we've had are as simple as like some of the spitball ideas we've had is like, do we just say, hey, if there's a folder in your project called like generator, and we just say, okay, everything inside of that is an analyzer generator, like just kind of automatically put that into the pipeline. We've spitballed that level of kind of ideas for how we could make things better. But it is kind of, as Chris said, we have a number of other things we're trying to address first in our priority list. One of the big things we're working on is kind of a little bit of a V2 of the hosting APIs, because we want to make the Visual Studio experience around generators as awesome as possible. And we need to like make the APIs a little more flexible for Visual Studio so that it can run generators at like a much higher performance like level than we can get today for the original APIs. And so that's kind of our big focus right now, is really like building on the VS experience. And then eventually though, we do want to get to that like inner loop, like, hey, I have my own generator and I want to make it easier. Yeah, like Chris said, it's definitely something we've talked about, we've spitballed, and we have some ideas, but it's kind of like a little bit lower on our priority list right now.
It would be nice to just, pound generator and then stuff is happening, right? It's kind of like macros on steroids when you do that. So that brings me to my next question. So like there's somebody in chat is kind of asking the question, I think differently than I would, but I think it gets us started in the right direction. So basically the question is, how do you recommend custom attributes versus source generators? But I think the way I'll take this is like with T4, because you basically generate net new code to the project based off of some external thing, like another file. Let's say, take resx, for example, where you have an XML file, you read that, and then you generate a type that accesses the resources, for example. Like it's somewhat, I guess it's not clear in the sense that it's obvious how they are connected, but because you're generating to an external input rather than the compilation itself, it doesn't have the same problem as source generators, where the idea is you generate a new source based on other existing sources in your project, right? And given that C# doesn't really have a sort of keyword that you can extend or syntax you can actually add, how do we think about what's the communication pipeline really that it's a source generator author uses to communicate between the source code that it reads and the source code that it generates, if that makes sense? Any opinions on that, or none?
So,
yeah, I mean, sorry, you can go.
No, you can go.
Okay. Yeah, I mean, like the attribute kind of key has been a very, very common pattern that we've seen used, where attributes have always been there to essentially add metadata to code, and IL supports that. And that's something that we see a lot, where you just tag a method or a class with some attribute that says, oh, this is something I want the generator to be interested in, right? And we have APIs in Roslyn that can do that. And in fact, some of the things we've talked about in the newer APIs is in making this even easier and faster, because it's such a common case. So that the author can just say, hey, give me all of the symbols that are marked up with this attribute. One of the downsides we had originally with that was that often you needed to get that attribute into it, right? Like attributes are part of the language and they are part of the emitted code. And so it does kind of blur the line a little bit between compile time and runtime. One of the features we added in 16.10 was something called post-initialization. And so with that, you could actually, we had this idea that you could add source in before your source generator runs. So you say, oh, this is the source of the attribute I want to find, and I don't want to define it in a library. I just want it to be part of the generator, and then we'll build that into the compilation and make it available for your APIs later. So we've made that scenario a little easier there. But there's still the fact that you're putting an attribute, and it's okay into the attribute, you're still putting that attribute into the user's output code. So some people can get a little uncomfortable with that. And there are other ways. I mean, obviously, ultimately, you have complete access to the syntax. So if you really want, you can just trigger off a comment, right? You can just say, oh, whack, whack, some comment descriptor, and that's fine. You can use that as your hook if you want to. You have complete access into that. The attributes are nice because you work at the kind of symbol level and you say, oh, I'd like you to show me the actual code rather than just syntax. But certainly for some things, comments are enough, or even just by convention, right? If you have names in your method, you can use that to trigger as well. So it's really kind of up to the author. And there's obviously a contract there between the generator author and the user, and how you actually message that is up to you. And, again, attributes are a very common way to do that. And it's nice because we've had that for reflection and things, right? You stick a serializable attribute on it or whatever. And so it's a kind of a mental model that most users understand. But if you want to trigger it how, with some special mechanism, you can do that, and we don't stop people doing that. So.
Yeah, I think the other one, besides attributes, another common one is partial methods, where essentially generators, essentially that users will kind of write partial methods, and then generators kind of come in and fill in the gap. Like they're like, oh, there's that partial method. Like it's like you can say like generate reg, some regex, and you put like a constant in which one regex you want, and then the generator will come through and like push that out. Like that's another one of the big communication pipelines, and that's something we actually was enough of one that we actually took some time to enhance the partial. That's why we enhanced partial method in C#9, was specifically because there were enough requests around like that being a generator kind of hook or entry contract that we said, no, we got to make these better so that we can like make this experience like shine.
Yeah, can you quickly say what you made better? Because I honestly don't remember what we did.
So partial methods, if you go like way back, partial methods are really, they were actually, if you go back to history, they were introduced in language to support source generation. It was specifically done to support the WinForms designer. So the way the WinForms designer used to work is, if you've ever done WinForms, is the code generation was the C# code. They generate this like designer.cs file, has a bunch of C# code in it, and that's how they render the designer. But everyone's like, yeah, but when the code starts done rendering, like I need to call this method over here, and I need to do this. And so everyone would go in and edit that designer file. They put their like call my method when this is done. And then the next time you open the designer file and you touched anything on WinForms, it would delete that line of code because it would just regenerate what was on the screen. And so what we did was WinForms added this thing. We added partial methods so that at the end of all that code, you could say like, and it was like on init complete or something like that, init complete. And then all you had to do in C# was just put like partial void and void init complete, and it would just call your method. And the idea behind partial methods, though, was it was basically saying we want to have a hook that may or may not exist.
Yeah.
Like we're going to call this method, and it's possible that this method might not ever actually exist. And so that meant partial methods had a ton of restrictions. Like, for instance, they had to be void returning, because if the method doesn't exist, we can't exactly like manufacture a random value for you. It also meant they had to be you could not put accessibility on them. We just said, look, they're going to be private. Period. Like that is the only option you have here. And that didn't really work for source generators this current iteration. With the current iteration, it's like, no, this method's definitely going to exist. That generator better be creating it for me. Like I really need that. So we needed to have return types. We wanted source generators to be able to fill out public APIs. So we wanted them to be accessible. And so what we did was we basically removed all the restrictions. And the thing we key off of now is we just say that if you add explicit accessibility to a partial method, even if it's private, at that point, the method becomes required and you can do anything. Like you can add, has the flexibility of any other kind of like abstract member that you would have today. And so that really gave us all of the flexibility we needed to make generators work.
Yeah, and I mean, like the sort of original partial methods were, they were sort of a very lightweight event system, really, that you could get callbacks. And what was really interesting is they were callbacks from the generated code into the user code, right? It was a way of the user providing some extra code to go in. And now what we've done with partial methods is really the other way around. And it's the way that the user calls it, and then the generator fills it in. And so from that's why we need things like, return types and parameters and things. So that was one of the enhancements we made in C#9 to make that scenario much easier.
Yeah, one thing that I wish we could do is basically replace method calls with something. So, like for example, for the serialization thing, it would be nice if we could say if somebody calls, JSON serializer.deserialize of t, we intercept that call and replace it with something that we generated. Because right now the problem is we can't really change the user code, right? Which I understand why we do that, but like it does mean that if you want to benefit from source generation, you always have to effectively define new API surface.
Yeah.
And the problem is that the user basically has to change the way they interact with something. So as a library author, it basically means source generation usually means you're either building something new that is from the get-go designed with source generation, or you basically have to provide new APIs that somehow hook into that, right?
Yeah, and that was actually one of our very explicit design goals from day one with this feature. And it was, it's obviously not controversial, but like people do go, oh, well, I would love to be able to do this. And there's kind of two reasons here. And I mean, interestingly, actually, there's a comment at the bottom that's just popped up saying about what's your thoughts about source generation versus coder control. And that's kind of part of the reason, right? That although the generator can always add code, it can't change what the user's written, so you know that at least what you're writing, you have control over what's called into. And the second reason is a practical one, and that is just ordering. And that's that generators run unordered. And so if you allow generators to manipulate user code, then you have this problem of what if generator A changes something that generator B was expecting, and now you get into all sorts of very complicated problems. And there are ways to solve it, and we never say never on that. But right now, as always with the compiler, we design features as the sort of minimal set of things to enable the most features, right? And so when we design source generators, because you can never remove things from the compiler, you can only add things. And so really we say, well, what gives us 80% of the outcomes for source generators? And that's what we have today. It's unordered, you can't change code. And yeah, there are definitely use cases that would be nice to make nicer, but we get the majority of the goodness with it. And you can still use T4, you can still use other generation technologies that can replace user code if you want to do that. We're not stopping you. We're just giving you an easier path to do that 80% of adding code only.
Yeah, as Chris said, like there definitely it was an explicit design goal from the day one was like no code modification. Like this, in addition to like everything that's wrong with the user, like all the kind of user expectations you can subvert there, it makes the IDE experience basically impossible. Like if unchecked code modification, and I definitely would be highly skeptical of us ever having an endpoint where we just allowed unchecked code modification, where we basically like said, oh, generators, here's every source file in the project, just give it back to us, do what you need, chop them up however you like, give it back. I doubt we would ever like that, and the reason for that is just because like one of the big contrasts between like C# and some languages came before it, like C++, is we have very strong definitions of what code means. Like we have a really detailed spec, and it says if you do this, this will happen. If you do that, other thing will happen. Like there's and we take a lot of time to define that, live up to the definition, and make it so users can predict what their code's going to do. And the problem with unchecked code generation and code modification is that's gone. It's basically saying that the definition of what your code does is in the eye of the combination of the random order of source generators that ran on your code, and that's really tough to swallow. It's a big change. But like as Chris said, we understand that there are places like I want to hook a method call, or I want to do this, and like define places where generators could sort of do that. I think that is more on the probability scale, where it's like, okay, we're not like saying no, we're never going to do that. We're like, okay, let's hear more, let's talk, let's see how can we do this without subverting user expectations. Like let's have a conversation about it. We have not yet seen a great solution for it. There were some earlier prototypes around replace override that we had in the compiler like 5 years ago. That probably the closest thing we'd have to a solution there, but it's definitely something we are aware people want, but it's kind of like I said, it's on our not on our priority list for V2, but it is something we will keep like looking at. And if people have good ideas on how to make it structured, how to make it not subverting user expectations and not make it an absolute crazy experience for the IDE team to implement, because they do know where I live and they can find me if we make them do that. So that like we're definitely open to suggestions and back and forth about that.
Yeah, I think that there's this like what's it called? Post job and others. What are they called?
Like the IL weavers and IL rewriters. Yeah.
I think meta programming tools, whatever, right? But they basically like you can do interesting stuff with it, right? But like usually interesting, that where people really get, I guess, excited is like a logger attribute that has the like basically logs every time you enter or exit a method, right? Like it's cool to see that, but what's less cool is when your code doesn't work and you try to figure out why it stopped working, and then you take the basically the modified assembly, throw it in Reflector, open it for the first time, and then like, oh my god, that's what my code looks like actually at runtime, and then you try to figure out what went wrong. And yeah, I've done that a few times in projects that very heavily utilize these systems. And same with security in other things, right? Like typical example, you put a security attribute on it, but then for some reason the generator stopped running, or the transformer stopped running, and then your security checks never got embedded, and then you're like, oopsie, what happened here? And so there's a certain amount of like complexity that comes with when you basically have alterations in place, because either they run and then they cause problems, or they don't run and then cause problems. Versus if you just add yet new code, well, the code probably doesn't compile when the thing didn't run, right? So like there's a certain amount of like ease of mind, I guess, when it comes to that simplicity, which I really appreciate. But as a library author, sometimes you wish you had more power, right? So it's the inverse of that.
Yeah. And I will say with like kind of even what you said, the logger attribute, that does actually fall into like kind of more of the structured edits. It's like saying I want to have kind of a pre-post generation phase. Yeah. And when I talk, I guess one thing I didn't kind of like talk about when I said like complications on an IDE team, it's like one thing I really kind of like try to stress to people when we're talking about like C# and doing a feature and things like that, is that I think from the outside, people tend to think about the compiler, like how would I make this compile and run? And it's like that's obviously a critical part of the problem. But generally, when we do features, we think about the entire ecosystem of experience. Like a language that has just a compiler is a toy. It is not a functional product. Like languages are defined by the ecosystem of tools that support them. Like what is your editing experience? What's your debugging experience? What's your packaging story? Like what is the entire ecosystem around it? And with modifying source generators, like one of the biggest problems you really have to think through is debugging. Like one of the really great things about source generators now is the debugging experience. Like we just tell people, hey, just step into it. It's right there. It's part of your application. But how do you, if you have like a piece of logging API where it's like inserting code, it's like it would be very, I think it'd be very wrong if that was silent and people couldn't see it. But like how do you make that debugging experience work? And so I think that kind of gets lost sometimes when people start making suggestions here. It's like you have to take that one step further. It's like, okay, we do that. Now, how do we show the user the debugging experience? Like, what clue do they get in visuals? Like, what clue do they get in the IDE on what's happening? Like, do we say that you can hover and like see the changes? Like, so those are the type of things that that kind of like just make us like sit in a corner and just go like, that's hard.
Yeah, no, I mean, like it's an interesting thing, right? Because also what people keep forgetting is that I think you use the phrase a lot, like you compile 1 million times a day, right? Because every keystroke logically is a compilation, because you have a snapshot of something that you present back to the user. And so then, when you're editing a method and then at the same time somebody else is injecting and removing or altering code, like what does it actually mean now when you invoke IntelliSense? What would you like to see there, right? And it's certainly.
I would say we attempt to compile millions of times a day. There's this illusion that compilers produce binaries. Really, we are a tool for generating diagnostics as fast as possible for the IDE team. The times we produce binaries is just this happy little accident that occurs a few times a day.
That's awesome. That's an interesting way to put it. Yeah, so one question from Daniel Smith is actually kind of a follow-up to this, which is since source generators can only add code, not altering, does it make C# extension everything more likely to happen?
I think it makes the lack of it more apparent.
I mean, to me, extension, everything kind of means you can extend something outside of that assembly, right? Or on a different type, right? That's usually what we mean by extension everything in the BCL, but I don't think that will be required here, right? Because you can just put partial on the type, and then the generator can just generate another file that can totally add new members to that type, whether it's instance or statics, and you don't really have any, like you don't really need extension everything to be able to extend the user type of a generator, right?
I think that some people have come to us and connected the two generators. Like they would say, like, why do, like, kind of an example of like, why do, if you want to make regexes better, could you do like regex dot like match and have it like keep the experience on top of that and use extension everything to kind of let generators plug the gaps in the background. Like we have heard that, like, let me add, I know a better way to write, like, hey, there's this type over here that has a constructor and like all the properties that are necessary on this other type. I'd like to just be able to say new, that type someone else owns, and pass my object in, instead of having go write like factory, which, like, you know, it does, extension everything really could allow you to put a lot of things together, and there is some intersection with source generators that you could see. But no, I think an extension everything, if something comes up, we actually, I think we made a stab at doing it about 3 or 4 years ago. We had a pretty good design. And it's one of the cases where we had a design that I think everyone was roughly happy with, and then we went to the compiler and we actually found out, like, oh, we made some really critical assumptions around how extension methods work in the compiler, and it was a massive architectural problem to move to extension everything, and so it exceeded our budget for that feature, and so we had to punt on it for that time. But it is something that comes up a lot, and I know it's something that we will revisit inevitably in the future.
Yeah, that makes sense. People are really amazed with the background noise. Is that your Rubik's Cube, Jared? Do you want to talk about it for a second?
So I have a history of having bad fidget toys. So my fidget toy previously was a Ninja Star. Why do I have a Ninja Star? Random. But I keep dropping it on myself and stabbing myself with it. So I grabbed the Rubik's Cube to be a less dangerous thing. But apparently the mic is picking it up. It also apparently bothers my wife, who works from home half the time. She can't throw a softball across the yard, but man, she can take that Rubik's Cube and all the way across the room.
What were you doing with that Ninja Star?
I have to fidget. Like I just can't sit still. There's another one where at one point, one of the guys who works with me, Fred, gave me an actual like little fidget cube. And I liked it so much that it was forcibly taken away from me in a meeting because no one else could concentrate because I was in the corner fidgeting with it too hard. And that fidget cube has disappeared and never returned.
So I guess there's a new business opportunity, a fidgeting toy that is mostly silent. That would be a good product for Jared.
Yeah.
So there's one question here that is kind of related. So like, I'd like to write React.js natively in my MVC project without having to compile it and bundle it beforehand. Would any of your tools help with that?
Not source generators. It's only on the C# side of things. I mean, I don't think T4 would either, but you could certainly, plug into the MS Build system. I mean, that is fully extensible in the May. I don't do a lot of JS front end, but I know there are tools that will do that and build into the build system. I mean, MS Build is fully extensible, so you could probably do it that way.
Yeah, it seems like it's the PhD thesis of web development, right? Because there's like a thing that changes every week kind of thing. I think Webpack was the choice for a while. I don't think it is anymore, but I'm not I think Gulp was also around. But it's basically like I think the problem is similar to what MS Build or linking does, where you just take some source files, do something to them, like minify them, bundle them, link them, and then put them somewhere, and then that's what you basically send back to the client. So it's related, but yeah, we don't have plans to cover JS in source generation.
Yeah, you could absolutely do that with MS Build targets, though. Just collect a bunch of files with various item types, then feed them into the compilers and inject them into the output.
For sure. I think we covered almost every question people had. If there's no more questions, I think we're already at the hour, so it's pretty good for us. Sometimes we go way over. Today doesn't seem to be one of those days. Yeah, I think there's one more question about Visual Studio getting better support for generators in the future, but we already talked about that, like debugging in particular. Yeah, one thing that we haven't really talked about is like, how do I see generated code in Visual Studio today?
Yeah, so as of 16.10, that is now supported in the Solution Explorer. So if you go into the dependencies node where we list analyzers, we now list generators, and you can actually expand that generator and it will show you all the files that are being generated. You can click on, you can go see the source code. You can set breakpoints and things in there. So if you want to debug your generated code, it's now really trivial to do.
And F12 presumably will get me there too, right?
Yeah, that will take you now to the, we show a little bar that says like, oh, this file was generated by this generator and you can't edit it. But yeah, things like find all references and go to definition work just as you'd expect them to.
Awesome. And then Mikayla, can you comment on how this works in VS for Mac?
I actually don't know. My Mac's been out of commission for the past month. I only just got it repaired.
Yeah, I think some of the, I mean, it's the same with VS Code, right? Like we have a level of support for source generators, but it's typically somewhat lagging behind where we're just, it's still, a lot of the stuff we're doing is still experimental. I think even the Solution Explorer is only 16.10, so it's still technically in preview. So we're tending to iterate there and then get the design, and then we're sort of pushing them out to other IDEs as we're comfortable with what we've got. So.
Awesome. All right, then I think that sums it up. Then, yeah, if people have more questions, if people found this useful, leave a comment. And yeah, ping us on Twitter or wherever you want, and ask for more information, more people, more topics to cover at the community stand-up. We're always happy to chit-chat. And then with that, I would say, yeah, have a great week, great weekend, and then I see you guys probably in 4 weeks, I believe.
Bye, everyone.
Thanks.
Bye-bye.